Hello everyone. Okay, so let's get right to it. Um, Sorry for that drop in audio from the beginning there. All right, so this first problem here. Okay, so step number one, you want to make sure that you are multiplying the coefficients and then the n values separately. We went over this in class, but you can line this up in terms of the associative property of multiplication differently. And that, remember, negative 2 n squared, negative 4 n to the fourth power, all of these are just products themselves. In that, sure, negative 2 n squared is being multiplied by negative 4 n squared, but this is really negative 2 times n squared times negative 4 times n to the fourth. So I can just line them up as such and then get me the product of these two, positive 8. The product of these two using the rule of exponents is n to the 2 plus 4, which is n to the 6, okay? So that's sort of this work over here. So for that reason, final answer, 8n to the 6th. Next question, same sort of thing. I'm going to line them up. 4 times 3 times 4, the coefficient first, and then my x values. X times x to the third times x, and then my y's. Y squared times y squared times y to the fourth power, right? So 4 times 3 is 12, times 4 again is 64. Wait a minute. No, 12 times 4 is 48. Sorry. So 48. And then remember, these x's all have an exponent value of 1. So this is really 1 plus 3 plus 1, right? So that's x to the fifth, my y's, y squared times y to the fourth, 2 plus 2 plus 2, sorry, 2 plus 2 plus 4 is y to the eighth. Final answer for number 2. Number 3, now we get to the power of a power property. Okay, now, when we're doing power of a power, just think about these separate products, once again, inside of the parentheses, meaning that this is really, if I'm going to rewrite this as products, this is really negative 4 times r to the third power quantity squared. So these are two separate products inside the parentheses. We simplify this by raising them individually to the second power. So that's negative 4 quantity squared, and then r quantity cubed quantity squared, still multiplied by each other. Negative 4 squared is just negative 4 times negative 4, which is positive 16. R squared quantity squared, this is the exponent rule here, where we are multiplying exponents. So that's r to the 3 times 2 is r to the 6th power. Final answer, 16r to the 6th power. Okay, next one. Okay, also, just products here. Remember, this is 4 to the fourth times y to the fourth times, and I'm going to use parentheses here because I already have a power of x here to the fourth power. And note that I can still write this as y to the first raised to the fourth power, okay? I just put that there because I know that that is just 1 times 4. It ends up being y to the fourth. So 4 to the fourth power is 256. Y to the first raised to the fourth power, 1 times 4 is 4. And x to the 4 times 4 is x to the 16. Okay, number 5. Now we are dealing with two properties. First, we have to deal with the power to a power and then the power of products. So this n to the fourth just kind of tags along for the ride. N cubed quantity squared, well, we know that this essentially over here, n cubed quantity squared is just n to the 3 times 2 is n to the 6. So this ends up being n to the fourth times n to the 6. Now we add exponents because we're doing product of powers. So n to the 4 plus 6 is n to the 10th power for number 10. Okay, number 6. E squared times negative 2b to the fourth. So if I'm raising negative 2b to the fourth, what am I really doing here? This is then negative 2 raised to the fourth times b to the fourth. And I'll write this here just so it's clear. This is b to the first to the fourth power. So these are the two products inside these parentheses. Negative 2 times b, both being raised to the fourth power. My b squared stays. Negative 2 to the fourth power. Negative 2 times negative 2 times negative 2 times negative 2, which ends up being positive 16. And b to the first raised to the fourth is b to the fourth. So that final answer, when I combine these b's, 2 plus 4 is 16b to the 6th. Okay, number 7. This is then 2 to the 4th times x to the 4th raised to the 4th power times y squared raised to the 4th power times now. This is where this gets tricky. This negative in front is really a coefficient that represents negative 1. So we want to treat it as such and make this negative 1 raised to the 4th power as well too. So that's sort of a new wrinkle that's important to consider. Times x to the 4th, also raised to the 4th power, times y squared, also raised to the 4th power. Okay, 2 raised to the 4th power is 16. X to the 4th raised to the 4th is x to the 16th, multiplying exponents. All these I'm multiplying. Y to the 8th, negative 1 raised to the 4th power is just simply 1. So I'm just going to cross that out. I'm not going to write it as being times 1. We have another x to the 16th, and then a y to the 8th. So we just combine these y's. This becomes 16x to the 32, 16 plus 16, because I'm doing essentially, this is really when I reorganize this. And these problems sort of end up turning into problems that look similar to each other, and that this is really all of these products multiplied together. So I have my 16. This is just 16 plus 16, the product of powers. And then my y to the 8th and y to the 8th is y to the 16th. Okay. Number 8. Negative 2. Okay, so I'm just going to start, just because this is similar work here, I'm going to start just writing this down and going through it. This is n to the 4th quantity cubed times m cubed. All right, so, oh my gosh, that is definitely supposed to be a 2, even though it looks like a D. That is a 2. So, and let me say this as well, too. This is important. That is negative 2 raised to the 3rd power, okay? So that's negative 2 times negative 2 times negative 2, which is a negative 8, right? Note this, and this is important, just so you can sort of cement this in your head. If you have a negative number raised to an odd power, the result is negative. Makes sense, right? Because think about 3. Negative times a negative, that's raising it twice, and then again is times a negative, because negative times a negative is positive, times a negative again is negative. To an even power is positive. So we have m to the 12th, 4 times 3, n to the 12th, also 4 times 3, m to the 3rd. So now we just combine m's, these two here, by adding exponents. So this becomes m to the 15, n to the 12th power. Okay. Number 9. Okay, here I'm just going to line up m, p's, and q's, just straight in the coefficients in order. Negative 4, 2. I'll put my m's first. M squared times n to the 4th. And this is a good idea, actually. I just do this because I sort of run through these problems. But it's a good idea when you're rewriting it to cross stuff out as you go. This way you'll know that you keep track of all the terms, you didn't miss anyone. So that was this m squared and this m to the 4th. So I've dealt with all my m's, and I'm checking that I've done so. Yes. Now I have my q's. Yep. So I'm crossing this out. My p to the 3rd, cross that out, and then p to the 4th power. Cross that out. Okay, negative 4 times 2 is negative 8. M squared times n to the 4th is m to the 6th. We'll put the p's first. Note that in these answers, everything is alphabetically in order, in that we go m, p, and q in the order of the alphabet. So I rewrote this. I'm just going to plop this over here at the end. P to the 3rd times p to the 4th is p to the 7th, q. So that final answer is 8m. Oh, did I forget a q? See, hold on. I forgot a q in here. See, I just looked up, and this is the reason why, and let me multiply it by this q. This q in here, that's the reason why you cross off. So I just happened to do it by detailing that strategy. But the reason why I noticed that is because I looked up at this problem and I noticed I hadn't crossed out something. So this final answer is actually q squared, because these q's combine at the end. So right, final answer, negative 8m to the 6th, p to the 7th, q squared. Okay, number 10. So we have 4m to the 4th. Why am I just rewriting that? That doesn't make a lick of sense. So once again, I'm just going to reorganize these in terms of their coefficients first, and then the m's, then the p's. So that's 4 times 3 times m to the fourth times m to the fourth. Okay, I can cross that out as I did before, times p to the third times p squared. Right. So 4 times 3 is 12, m to the fourth times m to the fourth is m to the eighth, and then p cubed times p squared is p to the fifth power. Okay. 11. Once again, this is just all being raised individually to the power of 3. Because, and we should probably detail this as well, but this, remember, follows this. It's called the power of products, okay? You have two products inside of parentheses. They're both being raised to the m. That means you raise a and b individually to the m power, okay? That's how this works. That's why I'm raising 2m and also n to the fourth individually to the third power. 2 cubed is 8. M to the third stays how it is. And note once as well, I'm just, because I know this is m to the first, I'm just sticking that 3 there because I know the result is going to be m cubed. N to the 12th power. Right. Yes, good. Okay, next one. 3 squared times z to the first quantity squared. And I should really use parentheses around all these, just because this makes sure that you take care of your negatives, and it makes sure that everything is order. So when you rewrite this, I've actually been displaying this badly. Should put parentheses for everything. Z to the first, so 1 times 2 is 2, and that is x to the 8th. So I put dots in between here, but this is really just 9. And of course, you would simply write this in alphabetical order. And, if you write this on your test not in alphabetical order, you're not going to be penalized for it. But that's how you'll see the answer in an answer key. 9x to the 8th z squared. Okay. All right. So this is x squared quantity cubed times y squared quantity cubed times z to the third power quantity cubed times y to the first power to the fourth times x to the third power raised to the fourth times z to the third power raised to the fourth. So you see, all I did was just take all of these products, these 3 products inside both of these terms, raise them individually to the third, fourth, fourth, fourth. Okay, so this becomes x to the third, y to the sixth, z to the ninth, y to the fourth, x to the 12th, z to the 12th. Now I just need to, and I'm going to rewrite this just so it's all clear. This is x to the third power, x to the 12th, crossing out as I go, y to the 6th times y to the 4th, crossing out my 2 y's here and here, and then z to the 9th, z to the 12th. So this ends up being x to the 15th, because I'm adding exponents, y to the 10th, z to the 21st power. Okay, now on to sort of more difficult results, in that this problem looks simple, but it's actually a little bit more complicated and not as intuitive. Think very carefully about what this represents. First of all, it's a fraction. Or in math, and you'll learn this later on, is called a rational expression, meaning that it's just a fraction that has variables in it, right? It's a term that's used as a fraction bar. You can think about this term as having a coefficient, or the n term as having a coefficient as -1, right? But beyond that, this is really just a product of 2 fractions. I am free to split this as being -1 over -3 times n over n, right? Or I can think of whatever the coefficients are for any of these rational functions as just being a split off fraction. And that's how you should think about it when you are simplifying the coefficients here. So why do I do that? I want to make sure that you're dealing with these coefficients correctly. So let's deal with this individually. The greatest common factor between both of these is -1. These negatives sort of divide out, and that becomes +1/3. Now, n over n. Of course, anything divided by itself is 1. but also per the quotient power property, we have a to the m over a to the n is equal to a to the m minus n. So when there's a division of terms that have powers, you are subtracting their exponents. So for that reason, n to the first divided by n to the first is n to the 1 minus 1, which is n to the 0. And then we know by the 0 power property that anything raised to the 0 power is 1. Okay? So that's how I'm dealing with this. And for that reason, I know this is just simply 1/3 times 1. My final answer is 1/3. Okay, so that's kind of a looks simple problem, but is relatively tricky. Okay, same thing going on here. This is 1 minus 1, right? So this is just simply 4 over 1, right, times x over x. X over x ends up being 1 as well, too, because anything divides by itself is 1, but also because of the 0 power property. My final answer here is 4. 16. Okay, so now when we start removing these coefficients 2 over 2, we get the multiple sets of variables that we have to deal with. So there's no other v's here, meaning that this is really v to the first, and then there's nothing I need to simplify. So this kind of comes along for the ride. I'll still keep 2 over 2 out here, right? And my final fraction v is still included. But u to the fourth divided by u squared is u to the 4 minus 2. So, and I keep that in my numerator as well, too. That's sort of an important point there. I'm keeping that right in my numerator because when you do that subtraction, your result doesn't bump down to the denominator unless, as we'll see later, there's a negative fraction. So this is actually removes everything from this denominator because I've done this division in here and removed the denominator component of the term. However, I'm not left with nothing. I'm left with 1. So what's my final result? This is 2 over 2, and this is not a final result. There's going to be another step. U to the 4 minus 2 is 2. Okay, what's 2 over 2? Well, that just simply is a fraction that divides to 1. My final answer is vu squared, or if you'll see it in the answer key is u squared v. Okay, all right. So we have 3 and 4. Now let's deal with all these a, b, and c terms individually. Okay, so we'll do all this subtraction in the numerator. I'll keep 3 over negative 4 out, but this is a to the 2 minus 2, b to the 3 minus 4, and c to the 3 minus 2. So let's deal with that. Oh, I put an equal sign here. That's not entirely correct. That's 3 to the 4th times. Right. Okay, so 3 over negative 4 will just move out to being negative 3 over 4 for right now. A to the 2 minus 2, that's a to the 0. B to the negative 1, 3 minus 4, c to the first power. Okay, so let's then deal with this fraction that results. I'll keep negative 3 over 4. A to the 0 is 1. Anything raised to the 0 power is 1. B to the negative first. Now you can consider this as a fraction. Anything with a negative exponent in the numerator bumps down to the denominator. So for that reason, my c stays, but my b moves down here, right? So what's my final result? Is just simply negative 3c over 4b. Okay, so all I did was make sort of my negative 3 and 4 come along for the ride. I stuck them as coefficients in front of whatever the resulting numerator and denominator was. If there's nothing, then it would just be over 4 in the denominator. Like, let's say there was no b, and this was b to the first, and b was up here. My result in the denominator is 4. So my fraction that I'm moving out is still being considered as, you know, a component of the numerator and denominator in the answer. It's just that you need to evaluate the variables using exponents before as well, too. Okay, so negative 3c over 4b. Okay. 18. All right. So this, unfortunately, because of time reasons, I'm going to split this video up into 2 videos. And this is going to be the last one that I do. I'm going to post Had some technical difficulties with this video. I'm going to post, I know that these are obviously the most challenging ones, 19 through 25, I believe, but I'll make sure to post 19 through 25 by sometime after school today. I'd say 5 or 6 p.m. I'll give you a written out answer key for it with written out explanations posted before that, but the video I'll post, like I said, 5 or 6 p.m. Okay. In fact, you know what? I'm going to save 18 for that video. So we'll start with 18 in the next video that I'll post, and then like I said, I'll post a full written out answer key. So not just the answers, all the full written out notes of every single question and how I got about the answer step by step by let's say definitely by the end of the day today. And then I'll post the answer video for 18 through 25. What's it called? By 5 or 6 p.m. tonight. Okay. Hopefully you learned a lot in those first couple of problems, and I will see you prepared for the quiz tomorrow.